This is the daily video for July 15th. Today what we're going to do in the course is we're going to look at this idea of what is called sampling variability. So far what we've seen is researchers are interested in learning about a parameter, but generally they can't calculate the parameter because they can't inspect every element of a population. So instead what they do is they use samples and they calculate statistics, and they use the statistic to estimate the parameter. And one of the things we need to be able to do that is we need that our sample, or what we call random samples, or in our case simple random samples. And that's because when we use simple random sampling, there's some really nice theoretic properties that we're going to be able to exploit. So far we haven't really talked about how we use the statistic to estimate the parameter. And today we're going to see one of those ways. And so this first way is what we call a sampling distribution. So a sampling distribution is a plot, and what it is it's going to be a plot of a lot of statistics. And what you're going to see happens is that if you take a lot of random samples, and from each of those random samples you calculate a statistic, and the type of statistic we're going to be calculating is what's called a sample proportion, and in the notes that I had you print out it describes what a sample proportion is. If you take a whole bunch of samples, and for each sample you calculate the statistic, and you make a plot of those statistics, what we find is that plot is bell-shaped, and it peaks at about the value of the parameter. So wherever that plot peaks at, we can use that as an estimate of the parameter. So what you're going to do today is you're going to, the first exercise you're going to do is you're going to simulate some data. And basically what you're going to do is you're going to take lots of samples. From each sample you're going to calculate a statistic, and then you're going to plot those statistics. And hopefully you're going to find that the theory holds true, that when that happens you really do end up with this bell shape, and it does peak at the value of the parameter. Now what would be really nice is if we knew something about that bell shape that we find that the plot of the statistics has. If we knew some characteristics of that bell shape, then we could use those characteristics and then apply those characteristics to the sampling distribution. And it just so happens that we actually do have some really nice properties that go along with the bell shape. So the bell curve is also known as a normal curve, and one of the really nice properties that a normal curve has is what we call the empirical rule. And so the second exercise you look at today is going to be looking at bell-shaped curves in general, and so you're going to look at that empirical rule and learn about that empirical rule, and then eventually what we're going to be able to do is to apply that idea to the sampling distribution, since the sampling distribution takes that bell shape. And so the next 2 days are going to be spent looking at the sampling distribution, the empirical rule, and then tomorrow how we can apply that empirical rule to the sampling distribution to learn even more. And what you're going to find is eventually by doing that we're going to get to that idea of confidence intervals and margin of error that you saw in the video, the videos that go with the course. Now one thing, I am going to offer some more bonus points today, and so let me talk a little bit about that. So in the first exercise you do today, you're going to simulate a sampling distribution. So if you would like to do the bonus points for today, you'll need to do them after you do that exercise. And basically what I'm going to have you do is I'm going to have you build a second sampling distribution. So at this point, what I'd like you to do for this video is go ahead and just pause this video, stop this video, do the sampling distribution simulation worksheet, and then come back to the video to do the bonus points. Now the bonus points, I'm going to give you a little more time to do this one. This one will be due at 6 p.m. tomorrow, so 6 p.m. on the 16th is when you'll need to email these bonus points to me. Alright, so let me go ahead and describe what I'd like you to do for the bonus points assignment. So hopefully by now you've already done that simulating sampling distribution worksheet. And in that worksheet, if you'll notice, I had the spinner was only split into 4 spots, so it was split into pink or blue, and we knew the true value of the parameter in that case was 50%. What I'd like you to do now is to basically repeat the exercise, but we're going to do this for a different parameter, and so that you can see that this still holds true. So the first thing I'd like you to do is on that web app where you spin the spinner, I want you to change the sections back to 4. So we had it with 2 sections for the worksheet, So just hit the +1 twice and that'll bring it back up to 4. So now on the spinner you should see 4 sections. You should see a pink one, a gray one, a blue one, and an orange one. Now we're still going to spin the spinner 20 times for each of our sample, and we're still going to be interested in the percentage of the times that the spinner lands on blue. So again, this is a special case where we know the value of the parameter. Since each of these spaces is equal, we know that even if we spent the spinner an infinite number of times, we would expect the percentage of the time it ends up on to be blue to be 25%. So what I want you to do is I want you to repeat the exercise and build a new sampling distribution. And what you're going to find is now that the parameter is 25%, when you repeat the exercise, your new sampling distribution should peak at 25%. So what I'm going to do for these bonus points are going to be worth 3 points on exam 2. So you get 3 bonus points on exam 2. And what you need to do is by 6 p.m. on July 16th is email me this sampling distribution. In other words, email me this new histogram that you've built after changing the spinner to have 4 spaces and keeping everything else the same. And hopefully you should find that sampling distribution now peaks at 25%, which is the new parameter under these new conditions. So you're basically doing the same thing you did in the worksheet before. We're just changing what the parameter is, and we're seeing if the theory still matches when we look at a parameter other than 50%. So if you have any questions about the bonus points, the best way to ask questions about the bonus points would be to email me. And if you have any questions about the material itself, go ahead and post that to the discussion board, and I will talk to you later.